Welcome to electrical machine lecture. In the previous lecture, we have already discussed the classification of DC generator, their types, then some circuit diagram of the different type of DC generator like DC series, shunt, compound. In the compound generator, again, there are two classification. One is the cumulative compound generator and second is the differential compound generator, isn't it? In the same times, we have discussed some circuit diagram and their some equation based on the application of KVL and KCL to the given equation, given circuit diagrams. Now, today we will solve some example so that we can visualize very well the type of DC generator and their calculation. So this is the first example. A shunt generator delivers 450 ampere and 230 volt, the resistance of the field and armature windings are 50 ohm and 0.03 ohm respectively. Calculate the generated EMF. So it is very simple questions. But at first, based on this type of generator, we will draw the generator diagram. Say this is the DC shunt generator. So shunt generator, it means that the field winding and armature winding, both are in parallel to each other. So say this is the DC shunt generator armature winding, and field winding is parallel. Field winding is parallel with the armature winding. So this is the DC shunt generator. It is connected with the load. So this is the load circuit. Now, what are the parameters are given? This is DC shunt generator. So armature winding RSH, which is equal to shunt field winding is 50 ohm. Shunt field winding always greater because it is connected in parallel with the generated EMF. Armature resistance is very small. It is a lower resistance, whereas the terminal voltage, it is 230 volt, and it is delivering the load current. Delivering load current is 450 ampere. Now, what we are going to calculate? We are going to calculate say EMF generated. So we know that first of all, we will calculate the shunt field current. If you are able to calculate the shunt field current, ISH, now it is ready to calculate the armature current, IA. So first we will calculate the shunt field current. So shunt field current, ISH. Now see from this circuit diagram, the voltage 230 volt is going to appear at this point, means across the terminal of armature terminal, and the same voltage is going to apply the shunt field winding. So here also the shunt field winding terminal, the voltage across the shunt field winding is 230 volts. So we are not going to now here not going to drive some equation and all these things. Whatever the basic study of KVL and KCL we are going to apply. So here it is voltage V divided by RSH. So your ISH is equal to 230 volt divided by 50 ohm resistance, it is equal to. So if we just calculate, so it is equal to shunt field current is 4.6 ampere. So 4.6 ampere. It is very simple numerical is there. Now armature current IA, which is equal to, so IA, which is equal to addition of this one, to which we are applying the KCL at this point, we are applying here KCL. So Kirchhoff current law. So incoming current is equal to the summation of outgoing current. So it is equal to IL. This is current is IL, load current IL plus ISH. ISH. So which is equal to 450 plus 4.6 ampere, which is equal to 454.6 ampere is the IA. So here IA, we have calculated armature current. Now, once armature current has been calculated, it is quite clear the EMF generated EG, which is equal to the, what we are going to apply? We are going to apply here KVL, Kirchhoff voltage law. So EMF induced is equal to the voltage drop across armature resistance. Here the brush drop is not given, only terminal voltage. So EMF generated EG is equal to terminal voltage plus armature resistance drop. So it is a terminal voltage. We will write here terminal voltage. No need to write every time, just this is the first numerical. That's why we are mentioning here armature voltage drop for remembering or for understanding. So terminal voltage, it is already given 230 volt plus armature current 454.6 into what is the armature resistance? Armature resistance is 0.03 ohm. So which is equal to so 230 plus 13.6 volt. So addition of these two is equal to 243.6 volt. So this is the your EMF generated EG. So this is the end of the example first. So it is very simple. Now we will solve the second example. Second example is a long shunt compound generator delivers a load current of 50 ampere. Means first is a long shunt. Long shunt means the field winding encloses the armature winding. So armature and series field winding. So this is the long shunt. Here is the field winding, series field winding, which having less number of turns, and hence the resistance of field winding is smaller, similar to the armature winding. Okay, so you remember all this concept. So otherwise, if there is some mistake in the numerical, many times in the examinations, some printing mistakes are there, but on behalf of your numerical examples and numerical solution practices, it makes simple to understand the data solution. What is given? It is given that what is the armature resistance? It is a 500 volt. So we write the voltage across the load is 500 volt. So terminal voltage, it is 500 volt. It is better to write the given data. And the armature load current deliver means it is load current. IL is equal to 50 ampere. So your load current is equal to 50 ampere. Then armature, series and shunt. So first is the armature resistance, RA. RA is 0.05 ohm, whereas the series field resistance, RSE, the resistance in series field winding is 0.03 ohm, and shunt field resistance, RSH, is equal to 250 ohms. So this is your RSH, this is RSE, this is your armature resistance. Okay. And one more thing is then calculate the generated EMF. We want to calculate the EMF generated across the armature, inside the armature. Allow 1 volt drop, 1 volt drop, 1 volt brush drop. So this brush is the drop across 1 volt across each brushes. So this is 1 volt, this is 1 volt. So brush drop, simply we will write 2 volt. 1 plus 1, it's 2 volt, isn't it? Now again here, if we are able to calculate the shunt field current, it is clear or easy to calculate the armature current. Once the armature current we know, we can apply the KVL. First we will apply the KCL at this point and this one. So it is the armature shunt field current. This is armature current and this is load current. So now ISH. Simple. First we will calculate the ISH, which is equal to this 500 volt is going to appear across this point, and the same voltage is going to appear across the shunt field winding. So V plus RSH, which is equal to 500 divided by, how much is the shunt field resistance? 250 ohm. It is equal to 2 ampere. Very simple. Now IA, armature current, is IL plus ISH, which is equal to 50 plus 2 equal to 52 ampere. So we get the armature current also, isn't it? Now EMF generated, EMF generated it is equal to terminal voltage. This is terminal voltage. We are applying KVL plus armature resistance drop plus series field resistance drop, IA, RSE plus brush drop. Do not forget to calculate the brush drop. So here we can calculate VT, since the current which is flowing through the series field winding and armature winding is same. So simply we can write as IA RA plus RSE plus brush drop. Okay. So how much is the terminal voltage? 500 plus 52 into bracket armature resistance is 0.03, shunt series field resistance, sorry, armature resistance is 0.05 volt. Plus this is 0.5, this is 0.03, plus brush drop is 2, and the total voltage EMF generated is, just calculate. So this is equal to 50, 506.16 volt. Okay. So this is the answer of second numerical. Next example is a short shunt compound generator delivers a load current of 30 ampere at 220 volt and has armature and series field shunt resistances R. 0.05, 0.3, and 200 volt respectively. Calculate the induced EMF and armature current. Allow 1 volt brush drop. So again, first it is a short shunt. Short shunt means the shunt winding, it is across only the armature, not the field winding, series field winding. So it is this is parallel shunt winding, isn't it? This is your armature, RA, it is RSH, and it is a short shunt. So series field winding is not parallel with the shunt field winding. So it is a short shunt generator. And here the load is connected. Now what are the different parameters are given? We will write 200 ohm. So it is RA, it is RSE. This current is IA. This current is ISE. The same current because R series. So this is the load current. Voltage across terminal is how much it is given? It is 220 volt. 220 volt. This is 200 ohm. Okay. And this is the shunt field resist, shunt field current ISH. So here given data, terminal voltage is equal to 200 volt. Load current 30 ampere. This is 30 ampere. Then armature. First is the armature resistance. RA is equal to 0.05 ohm. RSE 0.3 ohm. And RSH is equal to 200 ohm. 200 ohm. Whereas brush drop 2 ohm. Okay. So now first we will calculate the ISH, RSH. So ISH, it is the first you have to calculate the voltage across these two terminals. So how you are going to calculate? It is the current in series field equal to how much? 30 ampere, which is equal to the load. Yes or not? It is quite clear because the same current is going to flow 30 ampere. So now voltage across or voltage drop across series field winding, which is equal to IL into RSE, or you can write as ISE into RSE. It's same thing. So 30 multiplied by 0.3, which is equal. So it is a 9 volt. 9. So now what is the voltage across these 2 points? Say we will give the name as this point is A. We'll write this point is say A and this point is B. So voltage at points AB, say voltage AB is equal to क्या हो जाएगा? What is the voltage? So it is voltage across AB is equal to 220 minus 9 equals to 211 volt. Okay, so this voltage is dropped. It is the voltage, this one, sorry, this is the voltage plus. So it is 229. Just a minute. So this voltage is 229 volt. Okay. Therefore, ISH, therefore, shunt field current ISH is equal to VAB divided by RSH. It is clear from this diagram. So it is equal to 229 divided by it is a 200 ohm. It is equal to 1.145 ampere. Yes. So now what is the total armature current now? Armature current IA equals to IL plus ISH. So which is equal to addition of these two currents, 30 plus 1.145 equals to 31.145 amp. Now calculate voltage. EMF generated. EMF generated EG is equal to, so it is VT plus IA RA plus IA RSE into RSE plus brush stroke. So here we are not going to club these 2 points because the current are different in these two sections. See here, in this diagram, the current is 1.145. Here the current is 31.145 ampere, whereas the current in this section is 30 ampere because it is different. So here we are writing the separate terminal voltage is 220 plus 31.145 into the field armature resistance is 0.05 plus 30 into 0.3 plus 2 volt. So the EMF generated EG is equal to 232.56 volt. So in this way, the EMF generated can be calculated from the different generators. So today we will stop. In next lecture, we will continue this topic by driving some EMF equation of DC generator and their calculation.